So hi guys, in this experiment we'll be doing about we'll be determining distance of the pulsars by studying their pulse strength. Basically, it's basically a radio astronomy, and we'll be studying the radio waves from the pulsars, and we'll be finding their distances. So it's a very simple experiment, and let's go with the experiment. It's the same thing. Go open video, login, PSL. The next size here we are going radio astronomy of pulsars, and we have to get access to a telescope, and in this we are doing radio astronomy, right? So we'll be asking access to the radio telescope. Accessing the radio telescope. As soon as you get the access to it, turn on the control panel. So now turn on that. Okay. After it's turned on, this window will pop up. Turn on the tracking. Click on slew, hot list, view select. So basically we need pulsars to study, right? And in this particular hot list we'll be having a set of pulsars, and they are given description like about the nature of their pulses. So yeah, we'll be using the list to find or to go to that particular location in the coordinate or geocentric system. We will be going to that particular region where we are receiving pulses. Okay, so and as this window pops up, you are having a list of pulsars here, and preferably take the ones which are having this kind of description like strong pulsars or strong pulse, or this one, good dispersion. Preferably take this because you will get a good readings. If you take a very weak pulse, I mean there will be very less amount of pulses, and it will be really hard to differentiate like what is a proper peak as such. So go with this. I'll be taking this. You can go with anything. Okay, so on this, yes, as you can see we are going to the region where the pulse will be received. Okay, so as soon as we go to that place, click on receiver. Here in this table you can see we have different frequencies, right? 400, 600, 800. So we need 3 channels to measure frequencies or to measure the pulses at different frequencies. So add another 2 channel. Here it is 400. You can keep it to anything. 400, 600, and we need at 800, right? So 800. The vertical gain should be equal to the horizontal gain. Okay, it should be 4, and it's not that you can make this one. No, it should be 4. Okay, vertical gain and horizontal sec should be always 4. Okay, remember that. And record, you should keep it on, and click on mode. You will start getting pulses. Okay, in this part. Okay, so just click mode. As you can see here, you are getting different pulses, right? Usually wait for like 10 to 12 seconds so that you receive some good amount of pulses. Okay, and so stop the pulses. Okay, click on OK, and the ID. I think this ID for this particular experiment is not necessary because the frequencies are what really important in this, not the ID. Okay, so okay here also. If you click S here, no need to panic, just your file will be saved, and you can go back to window, and there will be tools in the first window which you see at the radio astronomy pulsar page, or that in that particular window you'll get that thing. You can click on tools and you can click the radio analysis. It says radio analysis in that particular window. You can click on it and you will just arrive at this point itself, analyzer of pulsar data. It's the same thing. Okay, or if you just click no, it will directly take you to here. So click just click no over there. Okay, don't click yes, it will save your time. So as you can see here, we have received pulses at different frequency ranges. What you have to do is you have to measure the pulsars at what point or at what second the first pulse is received. Okay, so yeah, click on this part. This is the first pulse at the 600, and this is the first major pulse at 800. Okay, so yeah, this is for 400. So at 400 you are receiving pulse at 0.61, and for 600 you are receiving at 0.1, and for 800 you are receiving it at 1.18. So it doesn't matter, just note down the values. Don't just panic. Okay, this is less, this is extremely less, and here it is suddenly increasing. You just note down the values. It's the pulses which we are receiving at that particular frequency. Okay, don't worry about it. So to measure the time of arrival of last pulse, in this particular case we are taking the 10th pulse as the last pulse. Okay, so you should measure 10 pulses at each and every case. Okay, so you can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the 10th pulse. You should measure the 10th pulse at each and every case. Okay, for this case I measured at 400 only. So, and here at the 10th pulse is received at 11.82 seconds. We'll write that here. And in this case, you might get the 10th pulse at some different point. So you can go to that particular 10th pulse in this particular case for 600, and you have to note down the value of that point. Okay, this is the first pulse, and 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, this is the 10th, and here also this is the 10th pulse. So note down these values for the corresponding frequency, and this is the part which will be done. I mean, this is the end of the software and we won't be using it any further. So note down these values here, and if you want to measure the next pulsar, click no and just close all these. Go to the sleeve, hot list, view selected list, and you can click any of them, preferably the strong pulsars. So good dispersion, we can click on this. Okay, as soon as it reaches here, click on receiver. Okay, click on receiver. Same thing, add channels, set the frequency to 400, 600 and 800. Vertical gain should be 4, and click record. As I just exited or closed the tab without saving the file, it's just asking me, just click no. Be detected. Now record is on. Click remote. Click this here. Click the wait for the deposits. Note on the values, and item down to the value. And it's the same thing for the next pulsar as well. So now coming further, as you can see, I just came to this point again. You can measure the pulsar signals here, take down the values and write them down, and count the 10 pulses. That's it. So come to this point of calculation. We have taken down the time arrival of the first pulse and the time arrival of the last pulse. So number of pulses what we counted, that is the last pulse is the 10th pulse, and period of pulsar can be calculated in such way that difference between these two divided by number of pulses would give the period of pulsar. That is, here in this case it is 14.3 minus 1.85 divided by 10, I would get 1.245. For 600 I have some value, and for 800 I have some value, and the same thing goes for other pulsar as well. The relative strength can be written in this way. Okay, the pulsar which is having very less or very short period of time, I mean the short period of pulsar, is considered to be very strong. Okay, so very strong, and the one which is slightly greater than that is considered strong, and the one which is very high, you can just write it as weak, or you can number them and write their order in the, you write their order using greater and lesser symbol. It doesn't matter, but you have to mention the relative strengths. The one with the least period of pulsar is strongest or very strong, and the one with the very high value is relatively weak. Okay, and when you're done with this table, you can go to the main part of the experiment, that is finding out the distance. That is the major objective of this experiment. Okay, so here you can see they have already given you the frequencies. Okay, 600, 400, 600, 400, 800, 600, 800. So how is T2 minus T1 calculated here is, you know the value of time period of the first pulse. I'm mentioning it first pulse at the corresponding frequency 400 megahertz. You have calculated it here, right? It is 1.85, and for 600 it is 1.37. So the difference is, just subtract them. Always, it's always the positive number. If you are getting it in negative, you should just keep the positive number. That's it. So you get 0.48, and for 400, 800, you have the values here. 400, 800, these are the values. Please remember, it's the first pulse, not the last. It's the first pulse. So subtract them, you will get the value here. And for 600, 800, it's the same thing. And 1 minus f2 whole square minus 1 minus f1 whole square is calculated using this formula. I mean, they have given the formula. The frequency value should be substituted. That's it. F2 is 600, f1 is 400. You substitute the value, you get the answer here. You will get some values for this also. And distance is calculated using this formula. D equals to T2 minus T1 whole divided by 124.5 into 1 minus f2 whole square minus 1 minus f1 whole square, and the distance is in parsec. Okay, so as you can see here, we have the corresponding distance for the pulsar, that is 600 to 400, and the values should almost be equal for a particular pulsar, irrespective of any range. It should be almost equal. Like, it's just the order. Okay, it's 10 power 3, 10 power 3, 10 power 3. Okay, it's the order, not if this is 10 power 3, this should not be in 10 power 4. That is, if this is in 10 power 4, then that's wrong. It's basically saying it's a two different pulsar. Like you're receiving a pulsar at certain frequency. You're just changing the frequency doesn't mean you're changing the distance as well. It's the same distance. So you will calculate the values of calculate the distance of the pulsar for the corresponding frequency, and using the formulas, like you know the t2 minus t1 value you have already calculated, and this value as well, just substitute them in this formula, you'll get the answer. Repeat it for each and every case. This is for another pulsar, this is for another pulsar. Okay, so, and that's the whole experiment. Show all the calculations as well, and in the result you should mention this: the distances of different pulsars are determined and the relative strength are calculated and studied. Okay, and this is all about the radio astronomy of pulsars.